5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
This is About Space. America's return to space.
Hello, thanks for joining me on this episode of About Space Today. I'm Rick Potlock, reporting from the Washington News Bureau. Next week, NASA will be approaching 3 historic anniversaries. Though tragic, they have made NASA a better space agency. January 27, 1966, the Apollo 1 spacecraft and 3 astronauts were lost on the launch pad during a routine test due to an onboard fire. January 28, 1986, the Space Shuttle Challenger was destroyed 73 seconds after liftoff, killing all 7 crew members. And February 1, 2003, the Space Shuttle Columbia was destroyed during re-entry over Texas, killing its 7 crew members. Why bring this up? As the late NASA Administrator Christopher Kraft once said, had these disasters not happened, we, NASA, would never have gotten to the moon. And I would add to where NASA is today. After the Apollo 1 fire, the late flight director Gene Kranz gathered all the flight controllers that were on duty that day and told them to write the following words on their blackboards and whiteboards: tough and competent. Words that ring through today, as ISS flight director Courtney McMillan explains.
After the Apollo 1 fire, tough and competent became the mantra of the flight control team. Those are still the core of the principles and the foundations that we live by. I don't think that has diminished at all. Our key priorities are always crew safety, vehicle safety, mission success, and those don't alter. But what mission success means changes over time. Those folks that flew the early missions, they set the standard. They went through the fire for us, and we try to live up to the excellence that they demonstrated every day.
From the Washington News Bureau, I'm Rick Potlock, and now here's David Denault with his report on the medical research currently taking place.
One of the many experiments on the International Space Station, or ISS, is biomanufacturing. It's a new, cutting-edge technology for medical advancement that cannot be duplicated here on Earth. A special NASA report next on About Space Today. Are you ready to fly away on a dream vacation? For cruises and all-inclusive resort vacations, call D&D Cruise and Tours at 877-747-8631. That's 877-747-8631. And see us on Facebook, D&D Cruise and Tours, where your dreams become a reality. Most likely you're aware of 3D printing, which allows you to design and produce one-of-a-kind pieces for a variety of purposes. But what if you could use that same technology to manufacture biological materials, like new tissue or blood vessel? Here is a special report from NASA.
World of 3D biomanufacturing, a cutting-edge practice on Earth that is being tested aboard the International Space Station, or ISS. Dr. Mike Roberts, Deputy Chief Scientist at the ISS U.S. National Laboratory, explains why the space station is critical to biomanufacturing's future. We've been able to grow cells in a lab for well over a century, but gravity limits that growth to 2 dimensions. Cells can grow outward, but not up and down like they do in the human body. Also, lab cells are often in contact with the glass or plastic that contains them. But aboard the space station, our experiments will be conducted in microgravity. That allows you to build your cell models in 3 dimensions, without being confined to the bottom of a dish, or unable to grow in contact with lots of other cells. Biomanufacturing imagines the ability to someday grow a viable human organ. Organs are composed of specific tissue intersected by blood vessels. Most organs and thicker tissues in the body have a rich, complex network of blood vessels that provide nutrients and remove wastes from the living cells that make up the tissue. We currently lack the ability and the tools to engineer these highly branched living networks of vessels inside layers of tissues on Earth.
And according to Dr. Mike Roberts, the Deputy Chief Scientist at the ISS National Laboratory, there are other medical advantages to working in space.
Another medical advantage to manufacturing biological parts in space is the potential to bypass the body's immune system. Today, organ transplants from donors are prone to rejection because the patient's body perceives the new organ as a foreign object, and their immune system tries to attack it. But with the ability to grow tissue in space, a person could conceivably have their own cells used to make their new organ, which might avoid the body's rejection. 3 different types of biomanufacturing facilities will be tested aboard the space station. 2 of them perform in a manner similar to a standard 3D printer. They extrude cells in layers to build tissue. The third type uses powerful magnets to position the cells in place. Each of these 3 different approaches to bioprinting in microgravity will be available to medical researchers seeking to better understand how to engineer tissues and organs for use in repairing injury and curing disease on Earth. As Dr. Roberts notes, the 3D bioprinters represent cutting-edge technologies that could clearly benefit health outcomes on Earth. I think the ability to manufacture a fully functioning human organ will take some time, maybe a decade or more, but the knowledge we'll acquire to get there will also create interim benefits as we learn more about cell regeneration in space and its application to humans on Earth.
Continue to listen for more on man's benefits of space. And for launch dates and more, see us on Facebook. I'm David Denault, and this has been About Space Today.